Welcome to the Assembly of Silence Radio Hour.
Greetings, assemblers. Those of you who have been with us for a while will note that the intro has been getting shorter and shorter. I've received some, I think, very worthwhile feedback, and we'll be reworking this introductory section. And while I'm figuring that out, I'm just going to work with what we've got here. One of the new things that I am pleased to introduce to you this episode is what I hope will be an ongoing feature. This will be our first episode of the Assembly of Silence's Assembly of Science. I have the good fortune to know a couple of gentlemen locally who have some deep experience in the sciences, and we've had some interesting conversations off mic, and I've managed to convince them to join me on microphone for a conversation where science is kind of the main thrust, but there's, of course, a fair amount of other types of topics which we typically discuss kind of looming and lingering, and I think probably in future episodes to come more to the fore. So in this is actually the longest Assembly of Silence episode that has yet been recorded, and I think that kind of bodes well for the future. It felt like we had much more to discuss than we got around to, and this kind of just scratched the surface of some of the things that I hope we'll get into in some more detail. So I'm pleased to introduce Jeff and Jonathan, who happen to be brothers, and I hope you enjoy this conversation as much as I did.
So I think it might be worth saying, like, okay, I don't know exactly what kind of weeds we're going to get into here, but
wait, what are we talking about?
Well, I think that you had suggested that we discuss what science is, which seems like a pretty good starter if you're going to discuss science. Science, what's it all about?
Certainly that's a question that science is trying to answer.
So you'd think by now that there would be some kind of definitive answer to that, given the developments. We've gone quite a ways. Science is pretty well developed. I mean, there's plenty further to go, perhaps. It's all going to depend, I think, on what happens with our species, our relationship to ourselves and our understanding, and perhaps to the world that we're living in. So it's perplexing that, and this is fascinating because, okay, you are a scientist.
I am. I consider myself a scientist still.
And you've been working professionally in the sciences and in science-related industries for many years.
I would say, for me, science has been a journey of about 3 decades, and including a PhD in computer science and medicine, and a bunch of different work, most recently at University of Berkeley.
So that is Jonathan speaking, just so we can get the voice recognition going.
This is Jonathin.
And Jeff, are we calling you Jeff?
That sounds great.
Okay, good. So Jeff, you also have a background in science.
Yeah, my science background is in the undergraduate. And when I was about 30, I dropped out of being a career scientist and started being a farmer and applying elements of science to being a farmer.
So you did some time as a professional scientist, technician?
As more of a technician level person, because when you're in a field and they call it science, you have to have kind of an advanced degree.
We call it the club card.
The club card, right?
Is that literally what it's called?
Sure. The intro club card is a PhD, and then the premier club card is a PhD with an academic appointment at a large university, and then the gold rolled carpet is the Fields Medal and Nobel or whatever prizes that just make you the untouchables.
So I think what Jonathan is alluding to.
Untouchables. Now, untouchables is kind of an inversion term, right? Because the untouchables in the caste system would be those at the bottom.
Yes, yes.
I think that's really interesting that we can use that inversion. But untouchable, to some extent, also implies those who can't be criticized.
Yeah, exactly. That's the way I meant it.
Perhaps that's one of the issues that's happening within science right now, is that the hierarchy is determining what's admissible. Is that part of what's going on?
Well, I think that touches on a question about what is it we're talking about when we're talking about science. Because there's a bit of an industry of science, and that was what Jeff was referring to, which is there's a lot of federal funding and corporate work in science that is really only being done by a small fraction of people that hold the scientific worldview or practice a process which we would call science.
And so that would be distinguished from some who are working in technical fields that aren't necessarily operating from a scientific point of view. Is that correct? So we have this kind of, scientific community, and then there's like engineering and technology that's an adjunct and related fields, and there are certainly scientists operating within engineering and within technology, but certainly not everyone.
And I think everyone here at the table would consider themselves within the science realm, but not
I've always
necessarily.
considered myself to be interested in science, but I never considered myself a scientist until the other day when you told me that I was one.
No, well, there you go. Jeff considers himself a scientist. Yes.
Well, I feel like this is where the first and premise of the conversation comes back, which is when you ask the question, well, what is science and what is it all about? The answer, I think, depends upon who you're looking at and what they think. And I think that's one of the things that might be interesting to discuss is what are the different definitions or paradigms around what we mean when we say science in different contexts. And certainly the academic ladder of untouchables at the top and various people in niches below that where they have to maintain certain mindsets or behaviors in order to stay in that niche is one way of analyzing it. But you could look at it in a more pure way of what is the scientific method, what does it allow us as a method of discovery to learn about the world around us, as distinguished from other ways of thinking about experience.
It's fascinating that we have this concept of pure science. It's a term that's often thrown around. And then we have the sciences, right, which are sort of this collection of fields, some of which are more or less pure, right? So it would be interesting maybe to zero in on what does pure science really mean? What is the root of the whole phenomena? And then we can discuss the branches.
So to me, science has at least three distinct ontological entities that people talk about when we talk about science. The first for me is a process. So we talk about the scientific process, and lots of folks have talked about this from Kuhn and Popper and all the way through of this collection of evidence, independence, testing of hypotheses, etc. The second thing for me science refers to is the results of the process. So when we talk about science, we talk about the laws and hypotheses, the data that we collect, the stuff that is the result of the science process is another definition, which all folds into engineering and technology and keeps the buildings up and put people on the moon and builds our stars.
What else is in stuff, just out of curiosity?
Well, to come back, let me put a pin in that, because the third piece I think is actually important to answer the question you just asked. The third piece for me of what people talk about when they talk about science is a particular worldview that we can define reality based on objective, independent evidence and the alignment of that evidence. And that worldview has become somewhat pervasive in the Western world as the underlying foundation of the story of what's going on for a vast number of people. And it's one that I've held in the past as the definition of reality. And I think it brings up Jeff's point very clearly, where if you talk to someone who thinks that the scientific worldview defines reality, then they have a particular bent on understanding what's real and what we can define as real. And interestingly, even though I consider myself a scientist now, I no longer consider that the only way of seeing what's going on. And that opens up a wide-ranging and complicated conversation about experience and knowledge, what's knowable, how we know it.
That kind of falls into the realm of philosophy, and I think maybe that's where philosophy and science diverge, is in the question of whether or not an objective picture of reality can be formed. And perhaps when it comes to clear, concise thinking, there are some problems within the scientific worldview that on some level are continually being revealed to scientists as they probe ever deeper into apparent phenomena. So in the measurement process and what have you, and noticing how the quantum world seems to behave. Questions as to the degree to which we can form a cohesive picture of what reality actually is start to poke us. But getting back to this question as to, so pure science now we're talking about as being based on these kind of pillars of observation, experiment, collection of data, hypothesis.
Evidence, testing of hypotheses, falsifiability, induction and prediction. These are all elements that you can carefully frame together as a linchpin of both the process and the worldview.
So we can say that basically science is an edifice that's built upon these fundamental principles that connect to each other. They all kind of have to have some degree of agreement in order for it to form a cohesive scientific picture. And that's where some of the problems arise, because there are a number of different competing views on how to formulate a picture of reality. Cosmology jumps to mind as being a place where there's a lot of different ideas that can't all be correct.
Well, there is a long list of unanswered questions in physics and more generally in science. Physics tends to hold a self-defined, somewhat superior role within the classification of sciences. They tend to define themselves as, I generalize physics from cosmology that you brought up, as defining themselves as a more fundamental definition of what science is telling us.
What do you think of that self-assessment?
Well, you can understand why that might happen. You know, the things that happen in chemistry are describable under the theories of physics, but not necessarily vice versa. And the same thing if you were to look at biology, biochemistry, it's explainable in terms of what we learn in chemistry, but not necessarily vice versa. So there is a little bit of a natural hierarchy to how these things inform one another, these fields inform one another. But does that make physics more fundamental in some way? What do you think, Jonathan?
It would be more fundamental for those people who hold the scientific worldview as unalienable, that it's more central to what holds their worldview together. Is it more central to the nature of what's happening in reality? Well, that depends on your worldview.
Well, here's another question. If we were to say that physics is the most fundamental pure science, then would it be true that it would be a more accurate description of what's happening in biology than biology uses, like the terms of physics and the way that physicists think about things? If we were to try to apply that to biology or chemistry, it seems like it would be somewhat unwieldy. It's almost as if biology and chemistry are happening within domains that are so complex that to try to drill down on a physics explanation of it all is going to make it just impossible. It's like trying to write everything in machine language.
Yeah, you've hit it right on, exactly. I mean, I think physicists would be overjoyed if their descriptions of reality scaled to the kinds of levels that we are interested in at the biological level. 10 to the 6, 10 to the 8, 10 to the 10 atoms, to get some start of biological activity. But we have computational difficulties in the way we model physical reality beyond about 10 or 15 atoms at this point to actually do all of what we currently model as physics.
But it may also be that we have conceptual limitations where the different levels of scale don't have a comfortable interface. We have theories.
Well, now there's a huge gap. It's not even an interface. There's not even an interface yet. It's just
there really is not, right?
We have no ability at this point, if we do full quantum mechanics based simulation of all the physical interactions that we know of, that get even close to a full atom simulation of a cell, for example. We're 18 orders of magnitude distant. I mean, so there's not even a...
So I've heard it said, and tell me if this is true, that really when it comes down to it, quantum mechanics can only describe the functionality of a hydrogen atom. That when we start dealing with more complex chemical interactions, that the shells of the electrons and all the various interactions are really not fully covered by the theory. Is that correct?
I think it really depends on what you're talking about. I'm not an expert in quantum mechanics. I took quantum mechanics in undergraduate, and it got to the point where the math was math that I could do, but it was structured in a way where I could no longer have visual pictures of what was going on, and just wrote, symbol manipulation for me, and it became uninteresting.
That's another thing that I've heard about quantum mechanics quite often. It's said that they can do the computations and come up with meaningful results that correspond to observed phenomena, but that doesn't correspond to any picture of what actually is going on. So,
well, our pictures are built on a scale that's very different than what's happening at the quantum scale. We did the math behind the hydrogen atom and particle in a box and all these. These are intro quantum mechanics calculations. And yes, when you get to multiple atoms, the computations explode. They become... I'm not sure if they become just too large to handle, or if they actually can't be modeled by quantum mechanics. I'm not enough of an expert in that to say. But the deal going on with quantum mechanics right now is we actually don't have a coherent theory even for it today.
Why is that?
Well, we have what physicists refer to as the Copenhagen Interpretation. There's various interpretations of a bunch of math and observations, but there is no coherent theory.
That's the interpretation of the atom.
It's the interpretation of quantum mechanics. This is why we call them quantum mechanics interpretations. There's, pilot wave, and, there's on the order of 10 or 15 of these interpretations. None of them are all that satisfying. None of them actually really give us a complete theoretical picture of what's going on at the quantum scale. Now, there's a lot of different ways we might interpret this situation that we're in the middle of. A friend of mine actually wrote a book on it recently, but the Copenhagen interpretation doesn't make very much sense at all. It's kind of a mishmash of just doing the math, and it gives us useful predictions. That's what quantum mechanics does, and it's, to date, one of the most accurate prediction systems in physics.
But it's a prediction within a very circumscribed realm.
Correct.
So we're
very small, very...
We're kind of talking about an individual atom, in essence.
Basically, anything that operates on the Planck scale, size scale, quantum mechanics covers. Particles, atoms, and it's ridiculously predictive. It gives us the story of why the sun shines. It makes it so that the electronics in all of our cell phones and cars work. It is arguably, next to Einstein's relativity, one of the most predictive things we've come up with in the human experience. It's accurate, but it is not a theory. It doesn't have a cogent story that we can look at and have it make sense for us yet.
Well, and its main point of experimental disagreement is its inability to make the same kind of predictions that the relativity theory does, right? I mean, they're looking at different scales of things, but the two theories don't mesh with one another, correct?
Yeah, and that's one of the great unsolved issues in physics.
Because Einstein's theories predict things on a very large scale, quantum mechanics predicts them on a very small scale, but when you mathematically try to put those two together, they don't line up. They don't work.
And lots of physicists are working on this problem.
And they have been for decades now.
Well, Einstein was working on the problem.
Yeah, I mean, on the order of 100 years.
Right.
Much more so in recent years. And lots of theories have come and gone. Some, even recently, have been knocked down as not working based on data that's coming out of the collider in Switzerland.
It's not like we're going to keep disproving theories until we have the last one standing and then that one wins, because none of them, so far, there's nothing that has that promise to it. It seems like we need to discover something new almost. Is that where we are?
What you just described, though, is one of the central tenets of the social process in science, is that people put out hypotheses, they put out essentially stories about what they think describes the data and becomes predictive of new data that they'll collect. And then all the other scientists who are in the club, who have the right to actually attack it. And it's very confrontational.
But it makes a big difference where you are in the club, like which level. If you have the gold card or the platinum card, your theory has that much more clout. Yep. And if you're just living in an igloo or a yurt somewhere, then you basically have no voice. They won't even bother to attack you; they'll just ignore you.
You do have a way of, if you know how the system works, you can have a voice through publishing. You can publish even in open systems like the archive. You could publish papers, but if you're not talking the language that they understand, then they will ignore you.
Yeah.
So it is very much a closed system. But the basic premise is people put out hypotheses, everybody attacks them, and the ones that remain are the best hypotheses we have to describe the evidence and the observations that we make, and those become canon. Those become part of the central story people talk about when they say, this is our scientific understanding.
So then the question becomes the extent to which those attacks are based upon scientific objections to what's being proposed, or are simply politically motivated. Like I think it was Thomas Kuhn in Structure of Scientific Revolutions basically says that you have to wait for the old guard to pass before you can really have a scientific revolution. That suggests that there's a heavy dose of political inertia.
There is.
That really gets in the way of pure science, we could say.
There's people joke science progressing one coffin at a time. And I think there's some truth to that, especially when you look at the process of federal funding for research. So the way to make a really strong objection to someone else's hypotheses is to do an experiment that collects data that directly contradicts somebody else's hypothesis, makes their hypothesis not predictive of the data that you collected. Well, in the really interesting realms of science, most of those experiments are quite costly and sometimes take work and teams and hardware and hundreds of thousands, if not millions and millions of dollars to do. So you need funding to do it. And who are the people who decide if you get federal funding to do it? Well, a bunch of old guard scientists who sit in D.C. and sit together and read all the proposals for experiments to do.
And I would imagine there's also a host of other issues that arise with data collection and data management and, preserving the integrity of data. And then, of course, you have interpretation of data. So there's all kinds of fuzzy stuff all the way through that process.
And good-meaning scientists can make errors for lots of different reasons, especially when there's very clear stories about what is real based on the scientific worldview. Turns out the amount of software you have to write to analyze a lot of data is large enough that it will have lots of bugs in it.
Right.
And so one of the things that came up recently in my work at Berkeley was this question of how do we make sure that the analyses that we do, given that it takes a lot of software to analyze a lot of data, is actually giving us the answer that we want. And people have been promoting this idea of blinding, this idea that you write your software and have a way to run it such that you don't see the answers that your software will give you until you unblind at the end of the process. So your search for bugs isn't biased by making sure the answers you get seem reasonable, because each time you run it, you've written the program in a way to artificially not give you a correct answer. And then at the very end of the process, because it's blinded, you basically write stuff into your program such that it gives you wildly wrong answers during the process of writing it. And you have to test. It makes your testing process a lot harder. You have to go in and make sure that what you wrote is accurate on every little subpart of your software. And then at the very end, you take off the blind. You take off the parts of the program that make the answer wrong to give you the right answer. And
boy, that sounds to me like a whole other level of complexity where things can go wrong.
And yes, and this is the level now that a lot of scientists are realizing is required, because there's such a strong bias towards getting answers that conform with the complexity of our current science story, that given that there might be, 50 or 100 different major bugs in the program that you wrote, the process of debugging it, you're biased to think you're done debugging when it gives you an answer that looks like the science result you're expecting to get.
That's very true.
And so people have done this all the time, and retrospectively gone back and analyzed other people's programs, found lots of bugs that were biased against each other, but still gave a result that seemed reasonable, but was totally not the actual analysis they were looking to do of their data.
And it seems like, particularly when we're dealing with domains of scale where measurement is kind of dodgy, like if you're operating in the quantum level, like our ability to really get super accurate measurements, like how good are we at really doing that? Same on the cosmological level when we're talking about billions of light years. Some of it starts to appear like noise, and like any noise background, you can pick whatever pattern it is you like out of it. That's my concern. I think as we reach to the macro and the micro level, we're confronted with fields that we have limited ability to really accurately probe. And as a consequence, we're sort of like, well, I see things that suggest that it could be the thing that we were thinking.
This is a fundamental limit on the boundaries of a lot of research that's going on now. And it's why you see sigma limits being used to determine if the signal someone sees in their data represents a discovery or not. By sigma limits, I'm talking about numbers of standard deviations above a mean. So if you recognize that all the data we're collecting is some signal against some noise background, how strong does the signal need to be before the science community generally says, oh, this is an obvious signal. We see it now as not noise. And so you'll see, especially in physics, especially in particle physics, they'll publish a result. They'll say, well, we see this new particle and we see it at the 4 sigma level. So the strength of the signal is 4 standard deviations above the mean of the data. So it's not quite a result yet. And generally it's 6 sigma, and people say, "Oh, now it's a result." But this is the frontier.
Is that considered the threshold?
Many do.
Yeah. I can't help but ask this question. So what happens when the signal is the background? As in the case of cosmic microwave background radiation.
Then we don't find it. So if the signal is the background, we don't call it signal, we call it background. So in the cosmic microwave background, even though we call that background, that is a measurable signal. We do measure the cosmic microwave background. We have a couple satellites now that are collecting that as data.
But it is, yeah, and so it's in essence, in that case, it's considered a signal, whereas in all other cases, it would be considered the background.
And that's how they first discovered it.
Right.
It was the fuzz.
So now we've kind of taken a stab at a little while at the pure sciences, and I think I've pointed out some of the issues that are happening with it. Maybe we can talk a little bit about the impure sciences, because we've already shown that the pure sciences have their own level of dilution and questionable issues that arise, and then we have these other sciences that are perhaps even, some people have said, like social sciences, they really should never have called it science. But, nevertheless, right, we have a wide range of different fields which are considered to be part of the sciences now. And how do we fold all that into the picture? Is there a coherent thing here that we can refer to? Or is it really just a term that we've kind of sloppily slapped on a whole bunch of things that aren't really all that related?
I think when we get to describing the social sciences with quantum physics principles that will be there, I think that should really be the goal, right?
And when is that expected to occur?
I don't know. Sometime probably before we...
when we turn into a different species.
Right.
I think, yeah.
I think it's a really interesting question if that could ever happen. So, I mean, if you hold the scientific worldview that says the definition of our reality comes from objective independent evidence and the alignment of that evidence into stories, hypotheses that are attacked and the ones that survive describe what's actually quote-unquote real, then eventually one would imagine you could take quantum physics and use it as a description of all the rest of the kind of behaviors that are going on. I actually, if I were pressed right now, I actually don't think that's going to be possible. I think that there's much more dynamism in what's happening than we will be able to describe at the quantum mechanical level.
Well, there's also a coherent narrative in what's happening. And since we haven't been able to identify a coherent narrative in the quantum domain, it would be very difficult to construct a picture of what was happening in a coherent domain from an incoherent domain.
Wait, do you mean there's a coherent story about what's happening in the social domains?
Well, we can construct coherent narratives. Whether or not they're true is a question. And that's actually another thing that's interesting is that in the process that you're describing, a hypothesis is presented, attacked, and then whatever remains is the result, you could say.
Sure, the result of the science process.
But
we call them our theories now, and
but ideally,
we called them laws.
Okay, but ideally from like a philosophical point of view, wouldn't it make more sense if instead of it being a political process, which is really what the attack and the last man standing is kind of about, wouldn't it make more sense if we talked about what actually made sense? Like if we applied logical principles to analyze the proposals, and on the basis of that, we would kind of determine what was still worth considering.
So the people doing it would argue that is what they're doing.
Right. I know that. But is it what they're doing?
Well, I think that depends a lot on the different fields. And
I think it comes back to the story. One of the first things you said when you were talking about science, you used the word story.
Absolutely.
And I think in the scientific process, it's how good your story is that's really important. And then having all of the data to support your story, call it a hypothesis at that point or a theory, is what makes your story useful in application to what's really going on or what you can observe going on. And I think the coherence you're talking about in the social sciences come from the fact that these stories are not necessarily challengeable in the same way with data.
Well, I think some would argue that that's not the case, although data interpretation is a huge issue, and it's a lot of people will disagree about what the data is really saying. But
let's talk about economics.
Okay. Do they call it the science of economics? I think they call it the dismal science. Isn't that what they call it?
So economics, I think, represents an interesting case at the very edge of the social sciences that really isn't a science. And what Jeff brings up here is a really important point, and that is falsifiability. Is that within the hard sciences, if I present to you clear evidence that contradicts your theory, then you will agree that your hypothesis, your story, is not accurate. The difficulty with social sciences in general is that the stories that are presented are too falsifiable. There's lots of evidence that they collected that contradict their own story. Because the system that you're effectively trying to measure when you get into the social sciences is so complex, it's so differentiated, and economics is the hardest of all of these domains, that it's easy to come up with a bunch of data that disproves almost anything you say.
Or proves almost anything you say.
Well, of course, and of course the people who said it have data that proves it. That's why they've said it. And so I think there is a long tail, is a long gray tail of more complicated dynamics going on when you get closer to living systems. You get closer to independent agents that make choice, that lead it further astray from straight up data collection and objective hypothesis creation and testing.
But also, as far as we know, the physicists who were studying atoms a century ago, atoms have not changed that much in 100 years. But humanity, as a species, and what we are, and what the social sciences are essentially studying, we're continually evolving. We're changing quite rapidly. So can we have a similar type of approach with a phenomena that appears to be so rapidly changing and say that, oh, we can describe what this is, even as it's morphing into something different.
Well, sci-fi authors have posited that. I think Asimov came up with psychohistory, right? Like what you're describing is from, science fiction at this point. Like, can we come up with predictive models of large-scale human dynamics? So far, we haven't been able to do that, and I don't think we're very close.
It's interesting, the predictive aspect of science in general. We could say the sciences in some ways are addicted to the concept of being able to predict, that without that predictive capability, it really can't be considered science. And yet we have so many difficulties in predicting things accurately, even in some of the hard sciences.
Yes and no. I think that opens up an enormous conversation. Yes, there are certainly areas where we can't predict things. There are lots of areas, though, that we just take for granted now that are incredibly predictive. That we, as a species that evolved from apes, were able to put a man on the moon is a testament to a ridiculous level of predictivity in basic physics. All of our engineering, the whole tech sector, that's essentially eating most of the Western economy at this point, is all based on semiconductors. And that's all based on an extraordinarily impressive level of predictivity. So it really depends on your context that you look at it from.
Right.
Like from one angle, you can look at it and be like, wow, if we didn't have this norm, right, like the safety of modern cars as an example, right? Like they just seem normal to us now. But there's a tremendous amount of science that went into making cars orders of magnitude more safe today than they were 50 years ago.
Right.
And there's like example after example after example, and soon there'll be automated cars, and soon there'll be, drones and blah, 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 blah coming down the pike, all of which are dependent upon really unbelievable levels of predictivity. Now,
So
at the same time, I agree with you. There's also lots of areas for which we just are looking at it and being like, wow, we just don't know how to do that.
Yeah.
And I get energized about this because what I saw in the last couple of years at Berkeley was a sea change on a few points. One, people are collecting tons more data. Almost every field has decided collecting lots of data and writing software and using data science is the way to do modern science. And basically, everybody doing interesting science now is doing modeling. They're trying to build computer-based simulacra of the system they're studying.
Wow.
And those simulacra are no longer just
He's making air quotes.
Yeah, how do I say this? It used to be that when we made models, we just made them so they were like what we were modeling. Now people are building models that are, to the best of their fidelity, actually the thing they're modeling. And that again is a mental shift. So the cosmologists making cosmology models in the Fourier space of the exploding universe are actually putting all of the location of the galaxies in the positions they are in when we see them in the sky in their models. The scientists who are doing watershed modeling are modeling the actual amounts of water hitting the ground at a particular place in a particular watershed, and the percentage of it that goes up into the trees and down the hill and into the different plant types.
This reminds me of what happened in the markets when hedge fund engineers started to play the market using algorithmic trading. That in essence they had a model of how the market worked, and they interacted with the markets to make money using that model, understanding quite well how it worked. And by doing so, they changed the behavior of the market and got themselves into a lot of trouble initially. I guess they figured out the kinks after a little while. But
and now
we
it's
had
all
the savings and loan crisis, I think, as a result of that. And it strikes me as a distinct possibility that these simulacra will be so vivid and accurate that we will be using them as a means to modify the world that we're in, and we could end up in a similar situation where the models will no longer work because of our great understanding of what it is that we've modeled. Because we're using it for predictive purposes, and predictive purposes means we want to be able to interact with it and do something to it. So
There is a slight difference in that the markets required other human inputs in the way they behave, and we're working on expectations in these kind of models that the watershed or the locations of the galaxies won't necessarily shift based on human understanding.
Right.
At least within the science worldview, that's the way they see it. So
Yeah.
we'll see.
We'll see, exactly. Or we won't. It
But I think
may be quite some time before we notice that things have changed.
I think it's a fascinating future to imagine, that our simulations become accurate enough that we can start to make more informed decisions about things we're doing, such that we actually know the effects. If we take out this much water on this month from this lake, how is it going to affect the water availability 2 years from now downstream 50 miles if someone wants to raise a herd of sheep? I mean, that's the level where our current models are being built. And previous to these, we just had a chart that said, hey, in June, usually the river's at about this high. In March, it's usually about this high. And if we have accurate models, we're going to be able to understand the world around us to a much higher fidelity. And I think that's going to bring all sorts of useful and positive results. There's all sorts of other social change that'll need to come along with that, which we're nowhere close to at this point. But from my point of view, those will be net positives. If we can understand the world around us better, and science can give us better answers about what will actually happen if we do a result, and to a large degree, these are starting in the physical realm. They're starting in the physics realm. But in the social sciences realm, that's where it'll start to get really exciting. Let's imagine a simulation of a city that knows where all the people are, where all the buildings are, and what's actually going on. And we run a simulation. We say, look, what happens if we put $200,000 and we build a homeless shelter at this location? What's going to happen in 3 years? I mean, I'd much rather have policy designed that way than having a bunch of, ignorant leaders fighting with each other for their own political ends.
It makes sense. I see
but that's where we're heading.
I see some hazards, potential hazards that way, but I'm wondering what is it that you think about that, Jeff?
Well, it makes me think about what's going on right now with climate change denial, because here we have a situation I think that encompasses a number of the topics we've touched. There's a very, very strong scientific consensus that human activities are changing the climate in a certain way that is harmful to the biosphere. If we choose to measure harm as things dying and going away forever and becoming polluted to what our biology can handle. Extinctions.
People's habitats being destroyed. All kinds of harm.
Fire. It's just horrific. But I think if we agree that there is if we in this room can agree that there's a scientific consensus that this is really going on, it gives us a framework for looking at where's the science in the policy making? How does what science is doing inform us, not just as individual humans, but as a group of humans? And it becomes a non-scientific sort of a thing you're looking at that point. I don't know if we're stepping out of bounds of our conversation, but what science is able to do is now couched in the framework of hierarchy that it has inherently, as well as this political hierarchy that's going on and the power dynamic.
So there's an inherent political dynamic within the sciences, and then we have the political domain of all of the various countries involved that also has a tremendous amount of pressure that's placed upon the sciences, which really just muddies everything. It's very confusing, I think, on both sides of that.
This is an excellent point, and there is no good answer for it, I think, yet. It's one of the things that I got severely disheartened by my time at Berkeley, was that there's on the order of 1,500 faculty there, and they are, to a person, unbelievable, amazing scientists. The degree of expertise, you sit down with any of them, one-on-one over lunch, and I did with many, and it is by far the most competitive of the UCs. It's an amazing institution, But what made me disheartened was the degree to which we actually do really know what's going on that isn't being transferred beyond the walls of the academy. That just at one university, on almost every topic that's really important, there are experts there who have an amazing grasp of what is really going on. And to a large extent, they aren't treated in the larger political and social spheres as having that kind of expertise. They're largely ignored because, and I fault the scientific momentum of the scientists in the United States and in the West for not being more proactive at teaching the larger community of general public and of politicians, like what the actual value is of what they're doing. Because climate change is a great example. We have a very clear understanding of what's going on with our climate. It is not in doubt, period. It's just that the people who really understand it don't have political clout or a voice to people making decisions about how we structure our society or the kind of rules and regulations that we place upon the actors doing bad things right now.
It seems like to play the devil's advocate, this is an example of a scientific process where the data and the interpretation have been brought into question by some, right? And,
disingenuously, but yes.
Well, I mean, I can't ascribe people. I think that there are some, obviously, who are disingenuous. So there are political reasons why some people would do everything within their power to undermine an effort to control fossil fuels, for instance, right?
ExxonMobil comes to mind.
Yeah. So clearly those guys have a financial interest in seeing things.
They've been lying for decades. It's not even, I mean, the word disingenuous is kind. It's far more malicious than just saying that. But when someone actually lies for profit, the correct social thing to do is to ostracize them. And we just haven't gotten there yet as a species.
Well, here's a specific example. Right here in Southern Oregon, we've been having severe fires. And in the general press, that's been largely blamed on climate change. It's one of the first things that's mentioned. But from a firefighter point of view, and having spoken with a lot of people in the Forestry Service, a lot of it comes down to forestry management, mismanagement. Forestry mismanagement is really the main problem. You know, we've had a long history of battles between a rapacious timber industry that's done a lot of clear cutting and been really destructive to the forests. And on the other side, we've had a lot of environmentalism that has prevented areas from being touched for a long period of time that causes a lot of environmental problems as well, because you get a lot of choking in the understory and all the various problems that happen as a result of that, which deplete soil moisture and take up a lot of the nutrients in the soil and weaken the larger trees, which make them susceptible to the insects. And so the larger trees start to die off, getting rid of the canopy, making the understory drier. So none of that has to do with carbon dioxide. You know, and yet it's used politically as a tool to, you know, that's one of the things I'm really concerned about is that, okay, if you're going to make an argument, why would you leave all of that out? You know, it's so on the ground type of stuff, and what it ultimately does is it weakens the case if you're
on both sides. On
both sides, exactly, yeah. So I find it to be an incredibly frustrating issue and really difficult to navigate, particularly politically, but even scientifically. I think unless you're an expert, it's extremely difficult to come to a truly informed decision. And on some basic level, my gut feeling is of all the things that we produce as a species, as a byproduct of our industrial activity, at least carbon dioxide, there's a natural mechanism for dealing with it. It's a gas that the plants love, and we produce so many other things that are so incredibly damaging and toxic that make their way through the biosphere in ways that are devastating, So it's like, okay, insect population loss, is that due to climate change? I wouldn't be so sure. There's so many other things going on that are extremely damaging. And in my lifetime, what I've seen is the environmental movement, basically a large portion of it being transitioned from a set of causes, a set of issues having to do with, let's say, for example, toxic waste, right? So Superfund cleanup sites, the various things involved with that. Now, a lot of that has kind of all been folded into carbon dioxide reduction. And when I think about it, it's like, kind of odd that all of these other things that we're producing that are truly, clearly toxic are kind of a side story now. It's just everything now is being focused on carbon dioxide. There's something about my New York City bullshit meter that goes off when I hear that, So those are some of the, if I'm going to play devil's advocate, those are some of the concerns that I have.
Well, I have another devil's advocate I'll put on the table.
Great.
Have you looked at the human population graph?
Exactly.
I mean, it looks like a L curve, and it doesn't seem to be leveling off. So maybe we ought to look at how many people there are around and consider that some of the tensions we have with our environment have to do with a runaway population of humans, and start questioning why are we even doing all of this the way we're doing it if the net result leads to such bad outcomes. And this is a topic that you've brought up, Noah, around, if the prevailing worldview that we have is leading to bad outcomes, maybe we ought to look at the prevailing worldview and start asking, have there been other ways that humans have lived that have worked better than this? Because I got to say, when I walk around the United States today, I see a lot of strip malls and I see a lot of really unhappy, overweight people, period.
Well,
and I don't think many people like being in that situation. So,
well, it's interesting. I recently saw the World Happiness Index, and I was amazed that the United States was relatively high on the charts. And I'm thinking, if that's really the case, holy shit, are we in trouble?
Bullshit. That's bullshit. Anyone who's actually spent time in a place like Guatemala or Tibet, places that are dirt poor and most people are incredibly happy, know that the way in which the happiness index must be calculated has to do with, how many Big Macs and how many toilets there are. And it's a ridiculous Western-centric view that somehow this way of living works for people well.
Well, it's interesting.
It's written by people who don't actually know what living in other parts of the world is actually like.
Probably, but it's also interesting to note that something like the happiness index has a little sciencey kind of feel to it. Like, we see a lot of things out there in the media that are presented as if this were some sort of scientific measurement of happiness, as if that could be something that was actually measurable.
It's interesting. It seems like the way the media treats science, it's something that's good when the public is going to like what they have to say, and it's not good when it's something the public isn't going to like what they have to say.
Well, I think it has to do with serving the interests of power, fundamentally. Like, if a scientific result is something that's convenient, great. If not, let's make up something else. Let's get together a group to collect some data, and I'm sure that we can make it. We can make a graph that's going to look really good with that data.
Unfortunately, what you just described is a lot of social science.
Mm-hmm. Yeah.
And it's one of the tensions between social scientists and people in the hard sciences, because the hard sciences tend to come from the point of view that there really is an answer out there. And then if we take objective measurement, we take observations, create hypotheses, test them, turn them into theories, then we are making stories within science that match some answer that's out there. But in the social sciences, the system that you're looking at is so amazingly complex, and it comes back to one of the early points that Jeff made in this conversation, which is oftentimes the answer depends on the context of the person coming at the question.
So then can we call that science if it's that subjective? Because ultimately science was seeking for an objective description of reality. So can we really call that science if fundamentally it's a subjective question as to the nature of the material being studied and the perspective of the people doing the studying?
I think you can definitely use the science process on systems that are that complex. I think it's a mistake to think that science is coming up with an objective description. I think it's coming up with a description of objective reality. And I think, for me at least, this is one of the main sticking points I have now with holding the science worldview as primary, because our subjective experience is real. Emotions are facts, and our experiences, subjective though they may be, need to be treated on the same level as objective reality. And when you start to do that, a whole new realm opens up that is definitely not scientific.
So yeah, I think that what I would do is clarify that from the way I see it, that the fact of an emotion is that it exists, but it's not a fact that it indicates what's going on necessarily. In the same way that we can have a objective reality, but not an objective description. You know what I'm trying to say? That there's a distancing that has to do with subjective experience. So from my best effort, I could make a description of what I see going on that is as unbiased as possible from my point of view. And yet, it is still fundamentally a point of view, which is biased by nature, right? So experience of emotional phenomena has a similar type of thing. It's definitely happening, and I can describe it from my point of view. But objectively, is there an actual truth that's being revealed by that description of my emotional state? Maybe, maybe not. There's no definite correlation between emotional states and what actually occurs. I can attest to that, having been married for 10 years now, more. So sometimes you really feel like something is going on, and it isn't. And sometimes you are completely oblivious, and something is going on. You know, the emotional state isn't necessarily a reflection of what's going on in reality. Just as our ideas about what are going on, as objective as we may be, we can be completely honest and really do our damnedest to collect information, come up with some kind of a picture of what it signifies, express it as clearly as possible. Well, it's still just our point of view.
So here's a question for you, Noah. Do you consider your subjective experience, let's take, for example, an emotion. Mm-hmm. Let's say you're feeling sad. Mm-hmm. You can say, I'm feeling sad. Mm-hmm. Is that sadness part of what you consider reality in the way you just used the word reality a minute ago?
Sure.
So I think the answer is yes as well. But the way you said it just a minute ago was people's subjective experience isn't necessarily part of, quote, reality.
Well, no.
Did I misunderstand you?
It can be part of reality, but it's not necessarily reality. I can feel sad because my sister didn't call me on my birthday, right? But then I can get back into cell range and hear the message that she left, 2 days afterwards when I finally get back into cell range. So my sadness at the moment that I was feeling it was, I didn't hear from my sister on my birthday. But I was wrong. I just didn't hear from her that day because I didn't have cell phone reception.
So reality is defined by being never wrong?
Well, that would be the case if your emotions were true. But if I'm going to take information from my emotions as being real in the sense of equivalent to true, then that's not how reality works. Right? I take the emotions as an indicator of what's happening within me that's real. So I'm having an emotional response and blah, blah, blah. But I don't know whether it signifies an actual event or not.
But everything that's happening is within us.
Is it?
It's a great question, Jeff. Is everything that's happening within us?
Let's throw this to Jeff.
Jeff hasn't said anything for a minute.
No, it sounds like we're getting down to this philosophical question about about science and consciousness. I think to make it something that we can encapsulate in a conversation, we might talk about the term materialism. And for me, what that means is something that's built up into the scientific worldview, which could be described as this idea that there's an objective reality that exists of matter and energy. And because of these things we've learned in our hard sciences, we can imagine how the universe started. One of the current theories is a Big Bang, and we can trace through our quantum physics theories how the universe evolved to the point where it is today. And there's a lot of pieces that we can actually say, well, this makes sense. There's some holes in it, and there's some things where our relativity and our quantum mechanics don't match. But what we've been able to figure out is rather incredible. But the idea here that I'm trying to get to in the term materialism comes back to consciousness in the point that I want to make, which is that from a materialistic point of view, everything that exists because atoms and energy interact in the ways that they do that is predictable. And that builds itself up through the hard sciences in that hierarchy to chemistry. The chemistry works because the physics works. And so now we've got chemicals that interact with one another in this way. We build it up, we make DNA, we make biological systems, we work it all the way up to where we have something as complex as the human mind. And in that paradigm, our consciousness is a byproduct of the existence of matter and energy interacting in the way that they do. And I think that's a limitation that I feel like a number of scientists know this, but that our institutions and certainly the common view of most humans on the planet is stuck in that paradigm. And I think that makes it easy for people who are in political positions of power to use science as a bludgeon if they want to make a point, or completely dismiss it if they don't like what it has to say.
This is a very deep subject that I think goes in all kinds of directions.
Brings up the word for me, beyond.
Beyond.
So I think it's hilarious right now. If you go to a hardcore scientist and you tell them, I think there exists things in the world that we can't see and we can't touch, that interact in no electromagnetic way with us, that affect us, they would balk. They would say, what are you talking about? Spirits and ghosts and all these things. And then you just turn to them and you say, dark matter.
Exactly.
Or dark sector.
Or dark
energy. There's a huge controversy going on right now with the Hubble constant. And now people are proposing there might even be a third element to the dark sector beyond dark matter and dark energy, which is fascinating. But it's like, we have things in physics today that we know affect the matter of our universe through gravitation, for which there is a long list of evidence. It must be there. And it doesn't interface through light. It doesn't interface through electromagnetics. And yet, physics tells us it must be there. It is as close to what people used to think of as beyond science as anything. And yet, science is now saying, well, geez, things don't really add up, so there must be something else.
Well, but of course that's because there's the basis for the understanding, the present understanding of galactic rotations is a gravity model. So if we stick with gravity, then we need more mass in order to account for those rotations. But it could be that gravity is not the only story. So,
or some people have argued, somewhat unsuccessfully, that gravity must not be what gravity is. And
well, do we know what gravity is yet?
Well, we have a theory.
Well, we've detected waves, apparently, supposedly. And does that mean that we know what they are?
Philosophically, we don't know what anything is. However, the list of evidence that we have that supports Einsteinian general relativity is remarkably long. Like hundreds and hundreds of different buckets, each with thousands of observations in them that all support a very similar story of a four-dimensional space-time manifold that warps under
Okay, before
gravitational
we get
attraction,
into that, I
et
just
cetera,
have
et
to
cetera.
mention, just have to tie in with something Jeff was saying a
Of
moment
course.
ago. The irony, as far as from my perspective, is that the one thing that we actually do know what it is consciousness.
We do?
We do. We're experiencing it. We know what it is. It is experience itself, right? We are all having an experience.
Are we consciousness or do we have consciousness?
That's a good question. I don't know how to answer that question.
I think we have consciousness.
Why?
I think everything is consciousness.
Yes, I agree with that. That would be a whole other episode. But okay, why do we have it?
Ooh, the why question. So why is a really difficult question. So when you start talking about how or what or when, then you are in context. You can answer things about how with elements that exist within the context of the conversation. But the question why in English has this really interesting frame where the actual answer to why sits outside of the current bubble of context. It's right at the edge, but it basically defines, if you think of context like a sphere in some idea space, infinite dimensional space of ideas, there's some sphere of the context that we share. Why is what's right at the edge. So why does the car run? Well, you can't answer why the car runs with anything about the car. You have to talk about, the nature of gasoline and, the transportation system and all these things that aren't necessarily, if you talk about how does the car run, well, then you can answer with all things that are inside the context of the car. Now, when you start to ask, why do we have consciousness? Well,
actually,
consciousness is a big context bubble.
Well, no,
It's
I was
really
asking,
huge.
why did you choose we have it over we are it? That's what I was asking why about. But that was a very interesting thing about why.
I think that I would say that there's ways that consciousness is a bit of a story that we have about our experience, and I would use just a different word. I would use presence. I would use being as a English word.
But actually, here's an interesting thing: is that consciousness and science are related etymologically. Science,
Conscience.
yep, and the I think it has to do with knowing, right? So it would be with knowing is what consciousness is, right? And science, of course, is knowing, right? The pursuit of knowledge, you could say. So being is one thing, right? Having a sense of being, but then consciousness is also with senses. Sensing is knowing, right? So the senses are the instruments of knowing. Without senses, how could we know anything?
Senses fundamentally, at least in the Buddhist tradition, are consciousness. Like you have a consciousness of something, and that consciousness is a consciousness of a feeling or of a sense or of a visual stimuli.
Another model would be that the senses feed the consciousness, that consciousness is receiving information from the senses.
Sure.
All right. Why are we talking about this?
It was the distinction between having consciousness and being consciousness. It raises an interesting question in my mind about science and consciousness. Did we just discover science somewhere along the way? Like we were in the Dark Ages and thought the world was flat, and suddenly Da Vinci came up with science, and now we've been doing this science thing ever since? Or is
Bacon and Newton, but yeah.
right, exactly. Yeah, Newton was what I meant to say. But maybe it was Da Vinci. My point.
There's a good crossover there.
My point being that is maybe the fundamentally functional part of what we do with science, observing things back to our senses, coming up with a story about what's going on, and then checking in whether or not our story is matching what goes on after that. Isn't that what we do as human beings with our consciousness at the base level with everything we do?
Well, I don't know that everyone is checking. It seems like some people just take the story and run with it, and they're not checking to see whether or not it actually lines up with
right, because that's what I was getting to. Is that if it is, then why are we not all scientists in the way that the best scientists are?
The other thing that comes up from what you were saying there is that it seems that the materialist conception of what consciousness is, that it's kind of built from the particle, atom, molecule ground up, is probably a relatively new invention that does correspond with science. And prior to that, it does seem that most indigenous groups were really coming from a purely spiritual point of view, where everything was alive and everything had a spiritual dimension to it. So it's kind of interesting that at the intersection between the old world and the new scientific technological world, we have this complete reversal of spirituality, basically a transition into materiality, and in many respects, the obliteration of the spiritual dimension of humanity. You know, it's basically holding on by a thread. When you look at the traditional ways of viewing things.
Well, it is here in the West. I think in other parts of the world, it's a bit stronger.
Perhaps, although I think that, you know, having been
West
to
isn't
India,
there yet.
well, I mean, you could make the argument in a place like India that, and certainly when I was there, I had the good fortune to have a guide who was an extremely spiritual dude. And while he was taking us to the temples, he said, the people here have no idea what they're doing. It has nothing to do with religion or spirituality. They're just performing rituals. And I could see that what he was saying was true, that things had become kind of a husk of what they were. And his understanding of Hinduism in particular, that was his root, was very deep. And it's, you know, not for everyone to get into all of that. So perhaps it's always been that way, and maybe this is not any different. But when we were in Thailand, it was the same story. You know, the Buddhist temples were places where people went to do the same things that people do in the Catholic Church here. They're basically going to atone for their sins, to give some money to the temple, to the priests, and to hopefully get some good karma out of it.
I think these ways of living are available to people if they look for them, even if it's only by a thread. I think Jeff brought up a really interesting question about human beings and their wiring. And if you spend time around kids, they do act like little scientists. They do test. And I think subconsciously, moving into adulthood, even when the childlike nature of us has been beaten out of us by society, I think subconsciously we test as well.
Well, that's beautiful, because that suggests that science is fundamentally a natural process inherent within consciousness, which makes beautiful sense etymologically, and that each of us do have that capacity to not only be good scientists because of our faculties of consciousness, but also to be spiritual, because that's the essence of the conscious experience. So it's interesting that we've kind of started with science, and here we are back at a nexus between spirituality and science, which I think is a beautiful place to be. And we're also at about an hour and 15 minutes, which will make this the longest Assembly of Silence radio hour yet.
Excellent.
I feel like we could easily go for another couple of hours.
Oh, yeah.
But maybe what we should do is at least take a break for a minute here and enjoy an Assembly of Silence moment, which is us making atmospheric sounds into a bed of reverb, which you won't be able to hear, but I will. So it make just little sounds. That was beautiful. Thank you, guys. That was a real pleasure.
That was awesome.
Okay, we will see you at the next one.
Thanks for listening. If you like what you heard, throw us a bone by subscribing to this channel, visiting our social media pages, and hitting the various like, love, and clap buttons. We welcome all comments, criticisms, and random thoughts. Our email is silentassembly@protonmail.com. And if you want to be an angel, we have a Patreon page. We look forward to serving you again soon. In the meantime, remember, turn that thing over a few times before you pick it up and take it home.